Hey space fans, welcome back to the channel. When you think of rings in our solar system, what's the first thing that pops into your head? For most of us, it's Saturn, right? The undisputed king of cosmic bling. Saturn's rings are so bright, so magnificent, you can spot them with a basic backyard telescope. They're a celestial icon. But what if I told you that the biggest planet in our solar system, the colossal king, Jupiter, also has rings? That's right, Jupiter, the gas giant that could fit all the other planets inside it, has its own set of rings. But you've probably never seen them, and there's a good reason for that. Unlike Saturn's brilliant, icy halo, Jupiter's rings are faint, dark, and incredibly shy. They're like a cosmic whisper next to Saturn's shout. They're so elusive that we didn't even know they existed until NASA's Voyager 1 spacecraft flew past Jupiter in 1979 and caught a glimpse of them. Backlit by the sun, it was a total surprise. So the big question is, what are these ghostly rings made of, and why are they so different from Saturn's? Well, the secret lies in their composition. Saturn's rings are mostly made of chunks of water ice, ranging in size from tiny spakes to a few meters across. This ice is super reflective, which is why Saturn's rings are so bright and spectacular. Jupiter's rings, on the other hand, are made of something completely different: dust. Tiny, dark particles of rock and dust, not much bigger than the particles in cigarette smoke. This material doesn't reflect much light, making the rings practically invisible from Earth. So, where did all this dust come from? It didn't just appear out of thin air. The source is actually Jupiter's own family of inner moons. Think of Jupiter's for smallest, innermost moons: Metis, Adrastea, Amalthea, and Thebe. These little moons are constantly getting bombarded by micrometeoroids, tiny bits of space rock zipping through the solar system at incredible speeds. When one of these micrometeoroids smacks into the surface of, say, Adrastea, it kicks up a cloud of dust. It's like hitting a dusty rug with a stick. Now, Jupiter's gravity is immense, but these dust particles are so tiny that some of them are launched with enough velocity to escape the moon's weak gravitational pull. But they don't escape Jupiter's. Instead, they get captured into orbit around the giant planet, spreading out to form a flat, dusty disk. This is the main ring of Jupiter. The system is actually more complex than just one ring. Astronomers have identified four main components. There's the halo ring, which is a thick, donut-shaped cloud of dust closest to the planet. Then there's the main ring, which is the brightest part, fed primarily by dust from the moon's Metis and Adrastea. Further out, you have the gossamer rings. These are two much fainter, broader rings. The Amalthea gossamer ring is sourced from the moon Amalthea, and the Thebe gossamer ring is sourced from, you guessed it, Thebe. It's a beautifully organized system, with each inner moon acting like a continuous dust factory, replenishing its own special section of the ring system. Now, this is where the real mystery begins. If you think about it, this whole setup seems incredibly fragile. Jupiter is not a calm place. It's a chaotic, violent world. First, you have its immense gravity. This gravity should be pulling the tiny dust particles down into the planet's atmosphere over a relatively short time, geologically speaking. The dust particles are also affected by sunlight pressure, which can push them around and disrupt their orbits. And then there's the big one, Jupiter's magnetosphere. This is an enormous bubble of intense magnetic fields and trapped radiation that surrounds the planet. It's the largest and most powerful magnetosphere of any planet in our solar system, stretching millions of kilometers into space. The radiation belts within it are thousands of times stronger than Earth's Van Allen belts. For a tiny dust particle, flying through this environment is like trying to navigate a hurricane of electromagnetic forces. These forces should, in theory, mess with the particles' orbits and sweep them out of the ring system very, very quickly, perhaps, in just a few hundred to 1,000 years. So, how do the rings survive if they're constantly losing material to Jupiter's gravity and being blasted away by its magnetosphere? They should have vanished billions of years ago. The answer is constant replenishment. The rings aren't a static, ancient feature like a mountain range. They are a dynamic, living system. They exist in a delicate balance between creation and destruction. The constant bombardment of Jupiter's inner moons by micrometeoroids ensures that new dust is always being kicked up and supplied to the rings. It's like a fountain that never turns off. As old dust particles spiral down into Jupiter or get ejected from the system, new dust particles from the moons take their place. This continuous resupply is what keeps the rings from disappearing. The rings we see today are not the same rings that Voyager 1 saw in 1979. The individual particles have been replaced countless times, but the overall structure remains, thanks to those hard-working little moons. It's an incredible feat of cosmic recycling. This balance is so precise. If the micrometeoroid impacts were too infrequent, the rings would fade away. If they were too intense, the moons themselves might be eroded away over eons. But for now, the system is in a state of equilibrium, allowing Jupiter to maintain its subtle, ghostly crown. Studying Jupiter's rings gives us a fascinating window into how planetary ring systems work, especially dusty ones. These types of rings might actually be the most common kind in the universe, far more so than the bright, icy rings of Saturn. The processes happening at Jupiter-Moon impacts, dust dynamics, interactions with a magnetosphere are likely happening in countless other solar systems across the galaxy. So the next time you look up at Jupiter in the night sky, remember that it's not just a big, spotty ball of gas. It's a complex and dynamic world, surrounded by a faint, ghostly halo of dust, a testament to the chaotic yet beautiful dance of gravity and matter. It's a ring system born from violence and sustained by a delicate balance, a cosmic mystery that we are only just beginning to understand. Thanks so much for joining me on this deep dive into Jupiter's hidden rings. It's amazing what secrets the universe is waiting to share with us if we just know where and how to look. If you enjoyed this journey, please hit that like button and don't forget to subscribe and ring the bell so you won't miss our next cosmic adventure. Until next time, keep looking up.